Hi, this is the video for trimester 3, day 6, the in-class notes. The first problem here is given this function v of t equals 5t plus 10 gives the velocity of a person in feet per second. Evaluate and interpret each of the following exactly. Okay, so if we want v at 5, we're simply going to use the v of t equation. 5 times 5 is 25 plus 10 is 35. The interpreting part is we're looking at the velocity. So the velocity at 5 seconds is 35 feet per second. The velocity at 5 seconds is 35, and of course we always want units feet per second. Looking at the value of the integral, we're looking at the area between the curve and the x-axis. If this is a velocity graph, our y-axis is feet per second. Our x-axis is in seconds, so the area between the curve and the x-axis is going to be in feet. So if I want to draw this, let's say that this is the y-intercept of 5. It's a linear equation that goes up, a y-intercept of 10. And this goes up with a slope of 5. If I want to evaluate this from 0 to 5, I know that this point is the point 0, 10. This point is the point 5, 35, simply plugging the 5 into the equation as we did over here. And we've got this area between the curve and the x-axis that I need to evaluate. Because it is a nice geometric shape, I can find that area using the area of a trapezoid. This side is a length of 10. This side is a length of 35, which I'll average 10 plus 35 over 2, and then multiply by this height, which is 5, and I come out with a value of 112.5. So the interpretation is that between the times 0 and 5, if we start at home at 5 seconds, the net distance traveled from time 0 to time 5 is 112.5 feet north of home. North of home because this is a positive number. The distance from the starting point at t equals 0 to the distance from the starting point at t equals 5 is 112.5 feet north of the starting point. Just about every problem that we've done so far, we've talked about distance, but our equation isn't always going to be a distance function, the equation that we're working with. In this case, suppose the rate at which the value of your house is increasing is given by this equation R of t, where t is in years after the year 2000, and R of t is in dollars per year. So again, if we're going to evaluate and interpret each of these, R of t is simply the equation. I'm going to plug that into my calculator. If I've got the equation in my y1 and I plug in a value of 5, I get 10466, so 10,466. So it's tempting to say, oh, my house is only worth $10,000. That's not correct, because R is the rate at which your house is increasing. So in 2005, 5 years after 2000, the value of your house is increasing at a rate of, we always like to get those in there, at a rate of $10,466 per year. So we don't know what you, actually we do know what you paid for your house. We can see that. But let's come over and look at now the value of this integral. If my vertical axis is in units of dollars per year, and my horizontal axis is in years, if I've got some sort of a curve here, and it's exponential growth, that I want to look at the what the area between the curve and the x-axis, I'm going to multiply dollars per year times year, and I'm going to get that the space in here represents dollars. So if I need to get a value here, it's not a nice geometric shape. I don't have an equation for this, so I'm going to go back and I'm going to use my Riemann sum. And because we're not told how much accuracy we have to have, I'm just going to use an n value of 50. Use n equals 50. And when I use my Riemann sum in the program on my calculator, I get a value of 47245.79. So let's see what that means. That by 2005, because I'm going from the year 2000 times 0 to 5 years later, the value of your house has increased by $47,246. So by 2005, the value of your house has increased by $47,246. So it may be that there's been market fluctuation between now and between 2000 and 2005. Maybe it didn't exactly follow this exponential growth curve, but for over the 5-year period, that exponential growth curve ended up being a reasonable estimate. So at the end of 5 years, we can use that curve, and the space underneath there is the $47,246. So at the end of the 5 years, the value of your home has increased by that amount. Okay, so a couple fun things to work on here is using our calculator to evaluate integrals in a couple of different ways. So we have, one way we have is if it's a nice geometric shape, we can just use geometry and find an area. If I want to get just a rough estimate, I can use my Riemann sum, and if I'm not told how accurate it needs to be, I can pick a reasonable number that's not going to crash my calculator, and n equals 50 is generally a pretty good number to plug in. But we're throwing the dice and saying, about how accurate do we want to be? I want to look at two other ways that our calculator can evaluate integrals for us. And the first is to use the Math 9 button. So let's get our calculators out. If you need to pause this, go ahead and do that. So I'm going to take my calculator, and I've already entered the equations I'm going to need here, but in my y1, I've got the 3x cubed minus 5. And my other equations, you can see I've got it turned off. When I go back to my main menu, and I go to the Math button, and then go down to 9, f and int for integral. So I'm going to have the Math 9. And on most of your calculators, it's going to come up with this. So if I want to evaluate this integral from 0, the bottom number here is going to be the 0 because we're going from 0 to 3. And the function that I'm evaluating the integral, I have plugged into my y1. So I'm going to go to the vars, come across to y vars, and it is a function I'm looking for. And it's in the one that I've listed as y1. And then because I'm looking for this with respect to x, dy dx. I'm going to put an x value in there, hit enter, and it tells me that the value of my integral is 45.75. Kind of a nice thing to have. So 45.75. Just quickly, for some of you, your calculators will, instead of coming up with this thing that looks like an integral, will actually look like, let me go to my mode, will actually come up, and they call it the classic. So when I hit Math 9, it comes up looking like this. And as you can see in your notes, the first thing we're going to put in is the y1. So we've got y1, comma, which is over the 7, then our x, comma, and our lower value, which in this case on this integral is 0, comma, and the upper value on this integral is 3, close the parentheses, and we still get that 45.75. Very few of you have the calculators that use this notation, but I know 1 or 2 of you do. So I'm going to go back to the math print. So it'll be set for my next one. Okay, and on this next integral, so another way that we can evaluate an integral that our calculator gives us, I think is really a fun thing. So first thing we want to do is on our calculator, we want to have the window set so that this will look the best for you that it's going to. I want to set my x values to go from -1 to 6, and my y values to go from -1 to 75. So go ahead and take a second to do that. Pause this if you need to. And then I'm going to go to my y equals menu. I'm going to turn off that last equation that I used. I'm going to come down and turn on the 2x squared plus 1. So now when I graph my equation, it looks like this. So nothing new here, we're just graphing an equation. But I am going to now get the value of the integral with, I'm going to use my trace button, my second calc. So second calc. And if I look at number 7, it looks like a little integral. And my lower limit is 0. It's asking for the lower limit. And then the upper limit is 5. Enter. And how cool is that? That the value of the integral is the 88.33. And I really like that this just colors it in for us, and we see that we're actually, the calculator is actually calculating the area of that region. So I think that's kind of fun. So the area there is 88.33. Now the downside of this is that it doesn't allow you to then use that number for a further calculation. If you use the Math 9, the 45.75 is just on your calculator screen to be used. So that one's the one that you'll probably tend to use more, but I think seeing the picture of it's pretty cool. Okay, so we need to fix the notes on this one a little bit. For number 4, find the area between the curve y equals -4x squared plus 64, the area between that curve and the x-axis, from x equals 0 to x equals 10. So first we want to write the integral. So the integral of -4x squared plus 64 dx from 0 to 10. Well, it's really tempting now that I just got those 2 new ways to do this on this calculator. It's tempting to just toss that in and do my Math 9 and get a value of -693 1/3. But if I look at this graph, what I see is, I'm going to come down to the right graph. Oops. What I see, I got to change that window a little bit so I can go down below there. So I want an x max of 10, and let's go to x min of negative 75. So there we go. We can see that I've got some of my graph that's above and some of it's below the axis. So the area, all of this is positive area, but all of this, all the way out to 10, is negative. So I've got this little bit of a relatively little bit of positive, all of this negative, which is why I ended up with that negative 693 1/3. So that makes sense, except that this problem asks us to find the area between the curve and the x-axis. So I'm not looking for my net distance, where am I relative to where I started, but I'm looking for, if I were to draw this and use the sketch that I had from my calculator, I've got this parabola like this. I want to know how much area is here, and also how much area is here, and not be concerned with the fact that that's in a negative direction. I want to know what is my total area, or to use the analogy I keep using in class, how far did I run? I don't care whether it's north or whether it's south. I want to know how far the runner went. So we're going to need to know what this x-intercept is. So I've got my negative 4x squared plus 64 at a height of 0. So 4x squared equals 64, or x squared is 16. X must be plus or minus 4. So this must be the negative 4. This is positive 4 comma 0. So if I want to know the total area, I'm going to take the area from 0 to 4 of negative 4x squared plus 64 dx. And then I'm going to add the opposite of the area from 4 to 10 of that same function. So when I evaluate this on my calculator, the first integral, I get 170 2/3. When I evaluate this on my calculator, I get a negative 864. So if I'm going to take the opposite of that, the 170 2/3 and 864, I get 1,034 2/3. Now, a way I can easily check this on my calculator is to say, let's look at not this function as it's drawn, but the absolute value of that function, 64, sorry, from 0 to 10. And if I look at my calculator again, that's not what I wanted. If I look at my calculator again and come up to my y equals, I'm now going to come down here and math absolute value. I'm not sure how I got down to number 8. Math absolute value of negative 4x squared plus 64. And when I graph that, it looks like that. If I evaluate the integral of that, so let's come over to here and math 9, and I'm going from 0 to 10 of my y4. So now instead of y1, I'm going to come down and say I want y4 and dx. And it's thinking 1034. So the same number I got by adding those two together, 1034 and 2/3. So the absolute value function does help us out there. And if we wanted to see that with the second trace, second calc 7, with y4, so I wanted to be on y4 instead, from 0 to 10. Colors that in, and gives me the total value of 1034 and 2/3. So hope these notes help. Take a look at what's in the share notebook on the regular notes, and also take a look at the car and truck problem that we will have done in class. That's also in the share notebook. So hope this helps.